Hi everyone, today we are going to discuss about introduction of angle modulation, both FM and PM. So this is coming under analog modulation technique within communication theory. Myself Dr. Arun. So here which signal can modify while performing the modulation? So the two different signals are available while performing the modulation. One is message signal, another one is carrier signal. Out of two signal, which signal we can modify, which signal we should not modify? So the answer is obviously the carrier signal only we can modify. We should not modify the message signal. If we modify the message signal, there is no need of communication. You are already disturbed your message signal. So we can modify only the carrier signal. The carrier signal consists of three different parameters. One is amplitude, another one is frequency, the final one is phase. These are all the three variables are available. If you are varying the amplitude of the carrier signal, that will be called as amplitude modulation. If you are varying the frequency of the carrier, then it will be called as frequency modulation. If we are varying the pace of the carrier with respect to your message, then it is called as phase modulation. So in this three different pictorial representations also available. The first waveform representing amplitude modulation. So the carrier amplitude is varied with respect to your message signal. The second waveform representing frequency modulation. The frequency of the carrier is varied with respect to the message signal. So the both positive cycle and the negative cycles of the message signal will be represented in terms of frequency variation in your frequency modulation. In the frequency modulation, the amplitude of the carrier is constant after modulation. Similar manner in the phase modulation also, the amplitude of the carrier is constant. Here, whenever we are changing the frequency of the carrier, it will automatically impact the pace of the carrier. And also if you are directly varying the pace of the carrier, indirectly the frequency of the carrier is also vary. So that's why we are specifying both FM and PM is called as angle modulation techniques. So here in PM also it is almost looking like your frequency modulation only. So in your positive cycle represented the high frequency and the negative cycle is represented low frequency. Similar manner in your corresponding phase modulation, at the time of zero crossover points, the frequency variation will be present in your phase modulation. Different types of analog modulation techniques are available. You are familiar AM, FM and PM. So in AM, the three definitions will be represented in terms of pictorial form. Here, the first one is amplitude modulation. In the amplitude modulation, the carrier amplitude VC is varied with respect to amplitude of the message signal VM, but frequency and pace of the carrier is constant in your amplitude modulation. In the amplitude modulation, the carrier amplitude is varied with respect to amplitude of the message signal. Frequency and pace of the carrier is constant. So the information is preserved in the carrier by varying the amplitude of the carrier signal. That is called amplitude modulation. In the frequency modulation, the carrier frequency FC is varied. So you may increase or decrease with respect to amplitude of the message signal. So specifically we can specify instantaneous amplitude of the message signal VM. So based on that amplitude variation, the frequency variation will be present in the frequency modulation. While performing the frequency modulation, the amplitude of the carrier is constant. In the pace modulation, the carrier pace is varied with respect to amplitude of the message signal or instantaneous amplitude of the message signal. Here also the amplitude of the carrier is constant. Both FM and PM, the amplitude of the carrier is constant. The variable parameter is as per FM, the frequency of the carrier is varied. As per PM, the pace of the carrier is varied. So here we can observe one point is the first modulation AM, the amplitude of the carrier is varied, frequency of the carrier is varied in FM, and PM the carrier pace is varied. So here all the parameters are varied with respect to message signal amplitude. So the message signal amplitude is a common parameter utilized to vary the amplitude, to vary the frequency, to vary the pace of the carrier. So that's why the three different modulation techniques are available based on the varying parameter AM, FM and PM. So in the carrier signal is also called as modulating signal, band pass signal, high frequency signal. Similar manner, the message signal is also called as modulating signal, baseband signal and low frequency signal. So in the different textbooks, the terms will be different. Okay, sometimes they will mention it as baseband signal, sometimes they will mention it as message signal. So like that, the different terms they will utilize to represent the message signal and also carrier signal. What is the need of the frequency modulation? Why we are moving towards frequency modulation? What is not available in amplitude modulation? The amplitude modulation also we are comfortable to transmit our message signal or audio signal from one point to another point. It will also reach us long distance above 150 kilometers. But still we are moving towards another technique called frequency modulation. The main objective is to improve the system fidelity or quality of the message signal. Comparing with amplitude modulation, in the frequency modulation, the quality of the message signal at the receiver side is very good. So that's why we are more attracted with frequency modulation compared with AM. The AM, the quality of the message signal at the receiver is little bit lesser compared with FM. So that quality of information or quality of the message at the receiver end, how we are achieving. So based on the Superheterodyne Receiver, you can see when you are comparing both the block diagrams of AM receiver and FM receiver, one additional block is available in the FM receiver, that is called amplitude limiter. This amplitude limiter tremendously increases the quality of the signal. As per amplitude modulation, in the Superheterodyne receiver, after IF amplifier and next immediately you are having detector. But in FM Superheterodyne receiver, IF amplifier, next one is amplitude limiter, then only the discriminator or detector is available. In between, the amplitude limiter is the extra block present in the FM Superheterodyne receiver. The main importance is in the frequency modulation, the amplitude of the carrier is constant. The amplitude of the carrier is constant. In the amplitude modulation, the amplitude of the carrier is continuously varying. So if any amplitude variation present in the received signal, obviously we can recognize that is because of your noise. Okay, so then we can automatically remove by fixing a threshold level at the receiver side by using amplitude limiter. Whatever may be the amplitude variation present in the received signal, that will be eliminated. So we are achieving the maximum quality of the information at the receiver side. What are all the advantages and disadvantages of FM over AM? Advantages of FM over AM. The first point representing improving noise immunity or improving system fidelity. That means the quality of the signal is very high in FM compared with AM. Low power requirement to transmit the signal and also transmitted power remains constant. So because in amplitude modulation, before modulation and after modulation, amplitude of the carrier is constant. That's why the transmitting power also remains constant. No power is wasted and hence the efficiency is good. In amplitude modulation, we are achieving maximum 33.3% of efficiency. But in your FM, we are achieving almost 90% of efficiency. So there is no wastage of power. The efficiency is more or very good in FM. The final point is adjacent channel interference is avoided due to guard bands. In the FM, one station and another station in between the guard band will be provided to eliminate the adjacent channel interference. The disadvantage of FM over AM is large bandwidth is required in FM. It is specified as 200 kilohertz is the requirement in the FM. So in AM, the 10 kilohertz is the corresponding bandwidth is required to transmit an information signal. When we compare with the AM in the corresponding FM, the 200 kilohertz is the very large bandwidth. The transmitter and the reception system are complex compared with the AM, and also coverage area limited to line of sight. It is approximately 30 kilometers. Effective communication is up to 30 kilometers. So it will extend up to 50 kilometers. The maximum extension is 50 kilometers. But in AM, we are able to achieve 100 kilometers with effective communication. Above 100 kilometers up to 150 kilometers, you can achieve the coverage distance, but the quality of the signal will be little bit lagging after 100 kilometers in AM. So the applications of FM is radio broadcasting. Next, a majority of the FM radio stations, they are using this FM frequency modulation. Then sound broadcasting in television, police wireless communication, microwave communication, and satellite communication. So these are all the areas they are utilizing frequency modulation. This is the experimental setup of your transmitting studio, and this is the receiver side. We are going to use a normal radio to receive a FM signal. The operating frequency band of FM radio stations or FM radio stations 88 to 108 megahertz is the operating frequency of all FM radio stations. These are all the example radio stations available in Chennai. So here Allo FM, the 106.4 megahertz frequency, it is a transmitting frequency of the Allo FM. Radio 1 94.3, and the similar manner your Red FM 93.5. So like that, each and every radio station having unique frequency to transmit their own information signal, but all radio station falling between 88 to 108 megahertz. The types of angle modulation we are already specified. One is frequency modulation, another one is phase modulation. Frequency of the carrier is varied according to the message signal. Phase of the carrier is varied according to the message signal in phase modulation. So the first one is frequency modulation. As per the definition, in the frequency modulation is a modulation in which the frequency of the carrier is altered in accordance with the instantaneous amplitude of the modulating signal, keeping amplitude constant. You can see here the first three waveforms representing amplitude modulation, the second and third one representing frequency modulation. So in your first one, amplitude modulation, this is the message signal, first signal representing message signal. The second one is high frequency carrier signal. This carrier signal amplitude is varied with respect to your message signal. When you are going to connect these peak values of your carrier signal, you can get sine wave. Similar manner in the frequency modulation, so the sine wave is the message signal. The next one is high frequency carrier signal. The final one is frequency modulated output. Here in your positive cycle is represented by using high frequency carrier. Negative cycles are represented by using low frequency carrier signal. The unmodulated carrier signal is modified or varied with respect to the message signal according to the instantaneous amplitude of the message signal. So continuously our carrier frequency is varied to preserve the message signal. So similar manner here also you can see the digital signal we are applied as a message signal. Same carrier signal we are represented to realize the difference. If it is 1 high frequency, if it is 0 low frequency, 1 high frequency, 0 low frequency. So that's why the negative pulses are represented by using low frequency and positive pulses are represented in terms of high frequency. This is frequency modulation. Then next one is phase modulation. In the phase modulation, the modulation in which the phase of the carrier is altered in accordance with the instantaneous amplitude of the modulating signal, keeping amplitude constant. So here also the two waveforms representing phase modulation. The first waveform representing message signal, the second one is carrier signal, the third one is frequency phase modulated signal. So here the negative cycles represented here, phase is lagging, and in a positive cycle of the message signal represented, the phase is leading. So the phase is increased and phase is reduced here. So obviously the frequency will also vary by varying the phase of the carrier signal. So when we compare the same sine wave and the same your high frequency carrier signal, here positive cycle to negative cycle there is a 180-degree phase shift, and negative cycle to positive cycle another 180-degree phase shift. To differentiate the positive cycle and negative cycle, here the 180-degree phase shift will be present. So this is the difference because of the modulation index of PM. If the modulation index of the PM is very less, means the corresponding PM modulated wave will be like this, and if the modulation index or depth of the modulation increases, the phase shift will be more in the phase modulated output. So here two different types of FM modulations are available. One is narrow band frequency modulation, another one is wide band frequency modulation. Generally majority of the application we are using for wide band frequency modulation only. This will achieve long distance communication. The narrow band FM we are using for only short distance communication. So less than 1 kilometer we are using narrow band. So here within the wide band, how to generate that wide band signal? Two different methods available. One is direct FM generation, another one is indirect FM generation. In the direct FM generation, the two different circuits are available to generate frequency modulated output. What is the difference between direct FM and indirect FM means? The carrier frequency is directly varied with respect to message signal, that is called direct FM generation. In the indirect FM generation, the carrier frequency is indirectly varied by performing the phase modulation. So that means actually we are going to perform the phase modulation. Indirectly we are going to achieve a frequency modulation. That's why it is called as indirect FM generation method. So within that indirect method, the Armstrong method of FM generation method is available. That we are going to discuss in the next videos. Next one is types of FM demodulators. Here also the two category of FM demodulators available. One is direct FM demodulator, another one is indirect FM demodulators. In the direct, the slope detector and a balanced slope detector is available. Both the types are coming under frequency discriminators. The another two types, fastest relay and ratio detector, is coming under phase discriminator. The indirect method is phase lock loop. This is the another type of FM detector is available. So thank you all. We will meet again with another topic within FM and PM. Thank you all.